I'll just share it with you.
Thank you.
Okay. Okay, so first I'll introduce myself. So I'm Naama, as you introduced me, and I'm a graduate student in Ben-Gurion University in Israel. And I'm here to talk with you about my work on intelligent recommendation in citizen science. This is my thesis work. So first of all, I assume you know SciStarter if you already mentioned it, but just for whoever doesn't know it yet, so SciStarter is a citizen science platform which offers more than 3,000 citizen science projects that can be taken either offline or online. And she's our partner in this research. And to demonstrate what SciStarter is, sorry. So here is a project that it's called the Catcher, which users find vessels in the blood. So this is an example of a project. Do you all know SciStarter as a citizen science platform?
I'm not sure if everyone knows it. I know it because I've met some people from there, and I think Liuba has met also some people. But maybe you could quickly summarize it for the others.
Oh. Yeah, sure. So there are 65,000 users currently logged in SciStarter. It's not a so big community as Zooniverse, if you know it, but it still attracts many users. And there are 3,000 projects which it offers, but the main projects that we get data from, there are only 150 projects like this. And these are the projects that we used as a recommendation. So out of this 3,000, we use only 150 that we get data from. Okay?
Okay.
Feel free to stop if you have any question. So our goal in this research was to create a smart recommendation system so participants can easily discover the projects most suitable for them. And our hypothesis was that giving the recommendation, we can improve and increase user engagement in SciStarter and their participation in projects. Because currently, users in SciStarter, they have a very low retention rate, and they stay like just for 1 or 2 times in SciStarter and then they quit. So our goal is to increase their engagement and to make them stay by recommending them with projects that might interest them.
So can you just say one thing, maybe? Can you just describe one example project? So what can you do? You click on the project and then it invites you to do some actions.
Yeah, so if I come back here, so this is like one of the popular projects in SciStarter, and which the task here is to classify vessels in the brain. Yes. Here. So there are plenty of projects in plenty of research areas like physics or biodiversity, or with any psychology, everything like in your meetings. And people can contribute to this project by sharing data or classify data. And by these actions, they help researchers to do things with this data.
And how do as a normal person, how do I, why do I come and contribute to projects? Like, how do I find them, for example? Because I need to search by keywords, so people need to be very motivated, or are they shared? Like, how do you?
Okay, yeah, so this is a great question. So the users who come directly to SciStarter, and it's a platform that offers projects. So just by entering, they get if you can see maybe in later.
Okay.
Sorry. So just a minute. This is not the presentation. Okay. I have two. So just come back. Here we have more slides, so I can demonstrate it. So there are 3 projects of SciStarter here.
Okay.
Like iNaturalist, when you can share observations of biodiversity, and ckground, where you can share daily readings of precipitation, and Catcher, which I demonstrated before. And currently, in order to find a project in SciStarter, there's a search engine which looks like this. And here you can enter like keywords or anything you would like a specific location that you want to contribute to a project, because some projects happen in a physical location that require like a tropical area or near a water place. So here, this was the existing way that users can search for projects. And we came to offer a different way, which is a recommendation system, which instead of users to search for a project and to do it actively, we want to recommend them, and so they'll just get the offers from us. So these users are users who come directly to SciStarter and then choose a project to contribute to, and there are also users who come directly to the project sites. Like for each one of these projects, they have a special site. So there are users who were not SciStarter users and contribute directly to projects, to the project sites.
You can contribute without being signed in.
Yeah, you can.
Okay.
You can.
But the 65,000 people are all people that have made an account.
Yeah, they have account in SciStarter.
Okay.
But not all of them are active. And here is an image of the recommendation tool that is now exists on SciStarter. And I'm glad to say that even after our experiment, which I will later describe, so this recommendation system is still available in SciStarter. So if you will go later and sign into SciStarter and do some activities there, so you can get a recommendation that's suitable for you as well.
Mm.
So now I'll just describe our methodology. So we took data of two sources. One source was users' contributions to projects. As I described before, there are 150 projects that share data with SciStarter. And this data includes the user's contributions, like if a user joined the project, or if a user classify an image or share data. So all these activities are recorded and we use it as one data source. And the second data source we use are clicks that users perform on SciStarter. If they click on a project that interests them, if there's a search for a project and stuff like this. So based on this data, we designed 4 different recommendation algorithms. And we choose the state-of-the-art algorithms in order to check which one of them yields the best results and actually succeeds to increase the user's engagement. So the first algorithm, which is a naive algorithm, which is the algorithm that recommends on the most popular projects. And then the second algorithm is user-based collaborative filtering, which recommends projects that similar users to the target user have contributed to. Like for example, if Mark, you contributed to the project Starcatcher, and I know that I'm similar to you in a matter of the projects we participate in. We participated in the same projects, so I might as well like the project Starcatcher that you participated in. Mm-hmm. And also another algorithm is item-based collaborative filtering, which instead of user similarity, recommends projects based on item similarity. Like if 2 projects are similar and I participated in one project, then the second one will also be recommended to me. Mm. And I will also mention that we recommend only on new projects that the user haven't participated in the past.
Okay. Okay.
And the last algorithm is matrix factorization, and particularly SVD. And this algorithm directly predicts the relevance of a new project to a target user by modeling the user. It maintains latent factors, and with these latent factors, it can describe a relation between a user and a project, and then recommends on the projects which got the highest score. It is hard to explain it very in high level, but I'm assuming that if you have a background of data science, you know the matrix factorization technique.
Mm-hmm. Yes.
Okay, great. So any questions until now?
Maybe just one question before we move on. a lot of these will depend on how many projects per individual, like how many, a typical person, how many projects they contribute to in their lifetime. Can you just give some descriptive statistics of
Yeah,
that?
sure. So most of citizen science users contribute to only one or two projects.
Mhm.
And for us, it's like um, there's a threshold of two projects. So only if a user contributed to more than two projects, he gets recommendations, and users who contributed to less projects or didn't contribute at all, they get the popular recommendations, like
Yes.
the popular projects. And there's still like a small community in SciStarter of users who participate in more than 40 or 50 projects, which are called heavy users and are highly engaged with SciStarter, but they're only 10% of all the users. So it's a very small group.
10%?
Sorry?
You said 10%?
10%, yeah.
That's actually a large group.
No, I mean, Leo, that's exactly the number that Robbie gave last time.
Yeah, I know, but like, okay, yeah, I'm okay, yeah, sure. It's but it's over 65,000 people. That's
Okay, yeah. So I'll just okay, great. I'll just make it more clear. So out of the 65,000, only like 7,000 users are active users. There are many users who just sign into SciStarter and then they don't perform even one activity, or they perform one activity 2 years ago and then they never come back. And just 7,000 users are active users who are active in the 150 projects we get data from. So it is a small community, and 10% of this 7,000 is just 700. So it's not many users like this.
okay, yeah.
It's like us, huh, Leo. Out of 4,000, I think 300 are active on the Slack.
Mhm. Yeah. I wasn't saying we have more users. I was just yeah.
But 7,000 active is pretty good. It's still a good community, I think. It's,
Yeah, it's still a good community. So
yeah.
how large is your community you work with?
Well, right now we have 4,500 people right now, but active. Currently active, I would say probably around 300. But we're it depends on the programs that we're animating. So it depends a lot on kind of like animation of the program.
Oh, okay. What does it call, this platform?
Just one giant lab, Joggle, Jogl.
Ah, okay. So this is the platform user contributes to.
Yes, and so well, you can have a look a bit after, because there's a lot
Yeah.
of content, but it's not so much citizen science. It's more like open science. So it's more people trying to come up with research projects, not contributing to them, but more like actually like trying to lead and find, like it's not simple contributions. It's not just annotation. It's more like making a device that does something or something like
Oh,
that.
okay. Yeah. So it's even a bigger challenge to make them more engaged.
Exactly, like because this is like you're basically a research institute, so it's as challenging as running a research institute.
Yeah, but maybe you can also base on users' characteristics, like the research area or
Yes,
like
we,
this.
we, we do have the skills, so we know the skills of the people, and there's really there's many actions. You can follow people, you can comment, post, so you have all the social interactions. We have whether you express needs, you can annotate a need with skills. So there are many actions you can do that allow actually to enrich a framework for recommendation. But it's a complex network. It's not just user to project. It's user to many different things.
Yeah, I understand. For us, we simplified this problem just because we didn't have so many data. So, like a deep learning algorithm which we tried, didn't result with good performance just because of the very low traffic we have. So we choose to focus on like state-of-the-art algorithms which are known to be successful in these domains. and therefore these are the algorithms we choose. So based on this algorithm, after we implemented it, we tested them in an offline and online settings. And let's discuss the offline first. So in the offline experiment, there were all these 7,000 users were taken into account, and each one of them got a recommendation of 3 projects. And then we measured their precision, refined precision, and recall at 3, where 3 is the number of projects recommended for them. And we can see from this table that the algorithm that yields the best performance are user-based collaborative filtering, which are based on user similarity, and SVD. So also the popularity yields the lowest results in all metrics. And I'll just say one word about the metric refined precision. This metric is a metric we used from another paper, which defined a new metric, which is called refined precision, that takes into account project characteristics, like the project location or the project topic or things like that. And we wanted to see whether there is a correlation between the precision and refined precision for future work.
Okay. Can you just walk again slowly this slide? Sorry. First, what is offline in this offline experiment? What do you mean by offline? Sorry.
Just to run the algorithms on all users and to see, like we took for each user. Say you have 10 interactions with projects, so I take 90% of them, which is 9. So your first 9 projects you interacted with as a train set, and I take the 10%, less the project you participated as a prediction that I want to predict.
I see. From the old data.
Yeah, from the old data, and then I want to guess correctly this project, and then I'll know that my recommendation is correct for you.
I see. So that's exactly what we're doing right now, actually. So you did a cross-validation on the past data to see how each of these predicts the links that had been done before any thing was implemented.
Yeah, and also it's important that I do it chronologically. So I take 90% of the data which the user first interacts with.
Yes, because it's causal. Because yes, absolutely, that's absolutely right. And so let me finish. So precision. So I always confuse with all the thing. So this is the amount of true positive that are indeed found with your algorithm, and recall.
Yeah, precision is out of the recommended projects. How many are the user actually performed, and the recall is out of the project that the user, the prediction that I want to predict, how many are used in the recommendation.
Okay, and so behind the scenes, there's a cutoff somewhere you choose for each of them to define what is, because it's weights, right? You give recommendation weights, but you have to define a cutoff at some point to decide what is positive and negative, right?
Yes, but no, I didn't have weights on. Therefore the results are very low, like 20% or 30%, because this is a challenge. I need to be correct. From 150 projects, I need to get the one project that that you didn't participate in.
Yes. Okay. Okay, got it.
Okay, great. So after we did an offline experiment and we assessed that the algorithms actually work and have a result, so we continue to an online experiment, and the SciStarter helped us in taking the recommendation system to the wild, and then we tested it with 200 users who were assigned to one of the algorithms. So each user received recommendation from one algorithm, and then we wanted to check also metrics like this is metrics that we invented, because here instead of measuring metrics like precision and recall, we were more interested to check our hypothesis to see whether users actually increase their engagement and they actually use the recommendation tool. And therefore, we defined metrics that called rec-E, no-rec, no-E, and tool-E, where rec-E describes all events of users who click or viewing the recommendations and engage with the project later. Like I see the recommendation of Storecatcher, it catches my eye, and then I choose to contribute to this project. So this is the sum of the events of all users per condition. No-rec, no-E is a metric of misses, like how many projects the user did participate in, but we didn't recommend. Like we would like the recommendation system to recommend this, but the recommendation system didn't actually recommend it. So this is like a miss for the recommendation system.
Is it because you actively prevented the recommendation system to recommend it, or is it because it was just never shown to the user?
Yeah, it was just never shown to the user because the user chose to participate in Storecatcher, even though it was not recommended to him. So
when you say not recommended, it means like it's the top 3 that you show, right?
Yeah. So in the online experiment, we show first of all 3, but the user can click next and see more projects.
I see.
Till 10. But if he doesn't click next, or if he wasn't exposed to one of the recommendations, but he still chose to participate in a new project, Storecatcher, which he hadn't participated before. So for us, it's a fail because we would want that this user will get a recommendation of this project, but our recommendation system didn't succeed to recommend it to the user. And the last metric is tool-E, which describes all engagement with the recommendation tool, which is click on the project or click on the next and the previous buttons or click on the project image. Every click they made with the recommendation tool, which for us, because of this metric, we wanted to see how much the recommended projects catch the user's eye and made them interested in the project that they offered to them. And here in the graph, you can see all the 4 algorithms described before: item-based, user-based, popularity, and SVD. And also, we use a baseline group, which receives projects that from a SciStarter choice. So they're like a fixed group of projects the SciStarter offers, and it doesn't involve any intelligent recommendation. Featured projects. Yeah, like featured projects, exactly. And then we wanted to compare if one of our algorithms succeeds to increase and to perform better than the baseline. And here we can see that it actually does. Like SVD and user-based collaborative filtering received very high results in all metrics, and the baseline was the lowest. Also, popularity didn't yield such high results as expected, because it is also not an intelligent algorithm.
So just to walk through, so what you want is that the green it just tells you the person is more active, like it kind of like it's where you have most of the actions of the person, right?
Mm-hmm.
Blue, it's very, very selective. It's much more stringent. But orange, I thought it was something unrelated to the recommendation system, but it just shows that it increased the activity of the person regardless on the actual item recommended. Because orange is the things that are not recommended, right? Orange is just a number of activities on non-recommended stuff. So it's activity on the platform on stuff unrelated to the recommendation.
Yeah, that's correct.
So what it means is that basically what you show is that not only you improve stuff on the recommended items, but you also have a leak where the person becomes more active on stuff that were not recommended.
Yeah, exactly.
Okay, I got it. And I have one last question. The featured projects in baseline, they're not random, right? They're actually good projects. They're kind of,
yeah,
they have an overlap.
Good is a matter of, it's not so Objectively, I cannot tell you if they're good or not. But,
I mean popular.
yeah, but the project that SciStarter chose that they want to promote.
So they're not random. It's not really a random control.
It's not random. We thought about integrating also random recommendations, but as for advice that we received from some researcher from the recommendation system domain, he told us that it is from ethically reasons, it is not a ethic to recommend on the projects that are random.
Interesting.
Yeah.
Interesting, because that's something we actually wanted to do with was showing in some like in the recommended items, show some of them maybe at random, or at least in a way that is not biased by anything, to actually have the control like trial. But I didn't know, like I would love to know more about the argumentation of non-ethics.
I think it is mainly because in our recommendation system, if I can show you, so it says here recommended for me and powered by AI.
Okay.
And
yes.
when the users were informed about the recommendation system, we tell them that it is an intelligent algorithm which takes into account their former activities, and therefore when we consider integrating random recommendations, we were told that it is a problem when we say it's an AI recommendation, and then we just choose random projects which may not fit the user interest, and then cause the user to be less satisfied with SciStarter, which is something we didn't want to cause.
Yes, no, that's a good point.
Because it is a great, when we use it in the wild, and SciStarter integrated is an integral part of its site. It is a challenge to not to make the users less satisfied with the site.
Yes.
So I'll continue. Okay. So after the experiments we made, we also wanted to check whether the users were satisfied from the recommendation tool. So we conducted a survey that included more than 100 users. And the survey included questions about users' overall satisfaction with the recommendation tool, and the questions about their pattern of behavior before and after the recommendations. And the results show that the majority of users, 75% of them, were very satisfied with the recommendation tool. And they claimed that the recommendations were suitable for their personal interests and goals. Here in this figure, you can see that we asked the users if you click on the project and interacted with it later. And we can see that most users actually clicked on the recommended projects and also engaged with it later, which is what the metric of REC-E, which was described before, shows. This is good results for us. And also we received, as you can see here, we can receive very nice feedback about the recommendations. And later on, we also wanted to wait. Sorry, I'll have a I'm sorry for all the confusing here, but I'll have another. The graph is in another place that I wanted to show. It's here. Okay, yeah. Here's what I want to show. So we were also interested to check to compare the users who received any recommendation, with users who were not exposed at all to the recommendation. So here in these two graphs, we compare between 7 groups. The first 5 groups are the algorithms which I discussed before. These are the 5 algorithms, and then we compare it with 2 other groups. First group called direct contributors, which are users who contributed directly to the project site, and they're not users who are signing to SciStarter, and they contribute directly to the project. And another group is users from past data, like users who were active in SciStarter a year ago. It is important to mention that some users can also be active a year ago and can also be active now. But we wanted to compare their behavior before the recommendation ever exists in SciStarter and during the recommendation, which is here split to one of these 5 groups. And we checked two metrics. One of the metrics was the average number of projects each user participated in. So as we can see, for all of the users who actually received recommendation, we can see that they participated in average in more projects than they used to participate before, and participated in more projects than users who contribute directly to the project. And also we checked for number of sessions of the users in SciStarters. Of course, for direct contributions, there are no sessions because they don't visit in SciStarter, but we can see that past users who were active before the recommendation was active, they spent less session than the users who were exposed to the recommendation. So we can see that we succeeded to increase also the number of sessions in SciStarter and also the average number of projects they contribute to.
It's interesting. Really, SVD is clearly out of an outlier. Is it because it doesn't just predict very, very similar stuff, but goes a bit kind of provides you also projects that are a bit out of your bubble, or like, do you know exactly why?
Yeah, it's a great thing that you say it, because during the user study, we received feedback from users who said that the recommendation exposed them to projects they haven't heard about it before. So even if the recommendation wasn't a smart recommendation, it still makes them more curious and discover new projects, which is another goal of the recommendation system that we succeeded to achieve.
I mean, yeah, I guess that is what being smart is, right? In that case, because that's the metric you want to increase. So if it works, it's smart. Like, you know, it might be smart to not be too accurate is what I mean. Yeah.
No, but it's interesting because it's basically it's something we have to look further, because it's something we want to kind of also emphasize, right? And the jump is pretty impressive in the number of projects.
Yeah,
I mean, it's literally 100% jump, right?
Yep. No, it's really crazy. I guess so. I have a few questions on this. Did you run the same analysis, but by clustering by user groups? So, for example, new users, right? Like if you're a new user, you've never been on SciStarter, and then you arrive, right? And then, like, you know, the number of projects you're going to contribute, like, you know, and the number of sessions you're going to be into based on the type of algorithm. Versus a returning user, so someone that's already been on SciStarter and is returning, right? And like and the changes that this induce. So that's like my first question, I guess, is that. And then from the past data, did you try to look at just that group of users that is from the past and keeps returning to SciStarter to see how this affected it?
Okay, so second question first. So for the past data, I'm looking for users who were active and are not active anymore, and users who are still active. So the group of past data can include users from the 5 algorithms and include more users that are not active anymore. It is meant to describe users, like the average behavior of users before the recommendation was ever exist. Yeah. Okay, and for your first question, so we take into account only returned users. Like for new users who just are new to SciStarter, I mentioned before that we just recommend them on popular projects because we don't have enough data for them. And as I said, we don't want to take them into consideration in this analysis, because we want to compare users who like their normal behavior, and not to take into account new users who the number of sessions and the average number of projects, it will affect the results here.
Yeah, that makes sense. Okay. Then one more question is, did you see an increase in the return rate, right? I mean, because I guess like the number of sessions per user is a little bit of a, you know, return rate increase, or like it's a proxy to that. But is it due to like do you see users that had stopped coming that will start coming again, right? Like, did you try to measure that sort of
it is interesting. I didn't measure it. I think it is interesting to measure it when the recommendation system is active for a long period of time.
Yeah.
Here we present the recommendation system was active for 3 months.
Okay.
But this is very interesting, and we are willing to test it in the future after the recommendation system will be active for more time, because here in SciStarter we have users who perform activity like two or three times a year. So if we want to check this, if they come back, it's better to check it on a wider range of the when the recommendation system is active for more time. But it is a very interesting question.
Yeah. This is really cool. Yeah. And it's also very interesting to me to see that popularity, which is one type of recommendation we see so often, is way worse than baseline, which is handcrafting, featuring by human input, being like, oh, those projects needs to be put forward, versus crowd filtering, which could be popularity-ish, right? Yeah, I don't know. I thought that was quite interesting.
Popularity, actually, what is the metric used for popularity?
Sorry, for popularity?
What is the metric used for popularity?
How do I know if a project is popular?
Yeah, what is used? Is it the number of contribution?
Yeah, an interaction with a project, either a click or a contribution to a project. And then projects who are interacted with the most, they're the most popular.
Okay.
Okay. So I think this is it for me. There are also another thing we integrated in the end. So besides the normal algorithms, we received recently data about the content of the projects, which include the project topic, which can be biodiversity or medical or physics, and the subtopic of the project, which describes better the topic of the project, the location of the project, if it is online or in a specific region, and the time that it is required to participate in the project, which it can be either 1 minute or an hour. And we take into consideration all these 4 algorithms to create hybrid algorithms based on our existing algorithms. So for each algorithm, we combined a similarity measure based on these features, and we took the projects that are most similar based on these features. So I won't describe here the hybrid algorithms because it is a little complicated to explain it in high level, but the main idea is to integrate between the existing algorithm and the content similarity that is based on these features. So here we can see a comparison of precision and recall based on all of the algorithms here. So we can see a comparison between the regular algorithm and the hybrid algorithm, which also involves content. And we see that with the integration of content, we actually succeed to increase the precision as well as the recall, which was very interesting for us to find. Unfortunately, we received this data just recently, so we didn't integrate it in the online system yet, but we are planning to do it in the future.
What is the number? The y-axis? Precision and recall.
Yeah, precision and recall.
It's actually reassuring. It's extremely small, the advantage it procures in a way. And I guess that's because, so the thing with topic in general is that it's pretty well encoded in the network structure usually. Like if you click on many projects, it's because they have some hot topics probably that are related in some way. So that the more you have network data, the more you can reconstruct actually topic. It leaks information in the network structure. So it's reassuring that to see that with just the network, you already have 90% of the precision.
Yeah.
Especially because the network is very, very crude here. What I'm interested in though is if you go back one slide, so, we do have location, we do have not necessarily topic, but we have skills. Something we wanted to test in our case was when you click on something, what you can see usually, you can see topic, you can see location, and you can see skills needed. Time, I don't know what time is here exactly. What do you mean by
the time that is required to complete a contribution in the project? It can be one second, like to tag a picture, and it can be 1 hour of contribution.
Yeah,
so
we don't have that actually. Ah.
Yeah, that's a good idea actually, to add like estimated time on a need.
Yeah, for the need actually, because it's supposed to be an atomized thing, right?
Mm-hmm.
But that's hard to compute as well. For like here, they only have one task ever to describe. Needs is something kind of like it might be a bit hard, but I like the idea.
Yeah, actually, this is a very like this data was manually done by experts from the field of citizen science, and it is very interesting because we tried before to integrate content into the existing algorithms, but the data we have, we also have data about user skills and like tags of the projects of related topics. But we saw that that the former algorithm we tried didn't result with high performance, and was actually worse than the existing algorithms. And by integrating smart content, which was done manually by experts that actually know the projects, actually succeed to increase the engagement, the performance.
And subtopic is like just you have two levels of hierarchy.
Yeah, like more classification, deeper classification.
Okay. Okay. That's interesting. What I would love, so what we're trying to do is to disentangle them, like because you know you can always do the marginal probability because you know, for example, if you clicked on something, you can compute what is the probability. It was because of the location, because of the time, etc. Do you have right now you're kind of integrating all of them, but do you have a knowledge on which one is actually the driver of the effect?
No, because I don't think I can know what is the trigger. I don't have I don't have data about the time it takes for a user to participate.
No, but you
or
could.
the topics that interest each user. So how can I know if which one of them caused the user to participate?
Well, because you can look at what they have actually clicked on, right, compared to
Yeah.
what they were exposed.
Also, you could just rerun your entire pipeline with just topic or just subtopic or just time and just location added, right? Just like add one at a time, measure the precision and recall increase,
Yeah,
and
you're right.
and there's just like defactor in, you know, what's
Yeah. So I did try it before, and I saw that most of the topic and the location are the main effects. But when I integrate all of them, I did like weighted of all of these features. But I see that like the highest weights are for the topic and location, which are which cause the highest
increase.
But when all of them together, it is the highest results. I also considered more features, like as we discussed, like skills or materials needed, but I saw that these features are not an integral part that makes users to contribute.
Yeah.
Also, I can add that in the user study, we asked users what makes them contribute to the project, and most of them talked about the topic and the task that is done. If the task is like a share picture or classify data, like the type of the task. But unfortunately, this data was not available for me, so I couldn't integrate it in the algorithm.
I mean, in your case, I don't believe skill matters a lot, right? Because you're actually, that's not really the requirement to participate. So it's really different than from our case, right? Where it's almost like a cross-mentoring across project or cross-help, like disciplinary field-specific help. But here you're asking, like it's more like similar to kind of a gamified Amazon Mechanical Turk, where it's about kind of participation for research, and people will look probably for like research projects they believe in and where the participation is intellectually interesting and satisfying, I believe.
Yeah, but for you, I think that the skills are a really great thing to integrate.
So that's something you're doing now, this hybrid case? Like you're actually...
Yeah, so we're actually done with it, with the development of the algorithm, and we're now working on integrating it to the online system, and we hope to see an increasement with adding the hybrid algorithms.
And so you are right now, Naama, you're still working with SciStarter or with Edinburgh on that?
So I'm from Ben-Gurion University in Israel. Edinburgh is the university which my supervisor works in. So I don't have any connection with Edinburgh myself. And I finished my, this is my thesis work. So I finished it in one month from today. So I won't continue working with the SciStarter anymore. But it was a great collaboration with them.
Okay, no, but that's very interesting. And so this new hybrid algorithm, so you said it was a bit too complex to share on high level, etc. But is it something you're gonna try to publish, or is it something?
Yeah, we're going to publish a paper on all of this work in the following month. Okay. And if you're interested, I can show you. Even beside this paper, if you're interested in the hybrid algorithm, I can also share it with you.
That would really be very useful, actually, I think. Because there are definitely maybe parts we can think of, whether it's in the methodology of the experimental methodology you followed, or even in the type of algorithms you've considered. It might be good that in our case that we try to benchmark in a way like the way you did. I really like, I think it's a, you know, it's very clear experimental setup, and I think yeah, it's a very nice outcome. So I would love that if we can have indeed more material. That would be very interesting.
Yeah, sure. I'd be happy to. It's my pleasure. Okay. It was great to talk with you about it also. And if you'd like to visit us in Israel, we would be happy. This is my lab here.
Ah, great. So whose lab is that?
Who's what?
So which lab is that? Who are the people?
This is the lab of Ben-Gurion University. We also perform meetings like Juggle, like you.
Okay.
Once a week. This is my supervisor, Kobe, and here is me.
Okay. So it's in between Israel and Edinburgh. I mean,
yeah, he works with both universities.
Okay. Okay, that's very nice. Well, that's very nice to meet you actually, because I think we can actually get probably a lot of interesting potential feedback from you as we develop this thing. You know, if you're interested to know a bit more about what we're doing with the algorithm, etc., we could even invite you to an upcoming meeting, and so that you could give us maybe feedback on
yeah, I'll be happy to. It sounds very interesting that you're a platform to all meet together and hear interesting things.
So yes, that's great. So are there questions from others in the group? Because I saw Lyuba that shared some comments earlier. Okay, so about the location thing. If SciStarter has any location-based solution, I would be interested. So maybe.
Yeah, it's similar with Joggle, because like we have the location of the user, and we can add a location to a project, right? But the problematic is like sometimes you want that location to be super wide, like say tropics, right? Tropical area. Like, how do you make a location be tropical area, and how do you make matching based on that? Is like, yeah, is a question that's
yeah. So I'm using an algorithm of Python, which is called Shapely, which for like SciStarter gives me for each project a specific region which it is able to take, which is identified by longitude and latitude points, and then there are like polygons. Of area which I know that the project can take place in, and then for the user I can just check if he's in this area or not over multiple areas.
Okay, so you just like basically, so the project leaders are giving you GeoJSON or like some sort of a like geopolygonal data on Earth, and you just match the user GPS with it's like in or out of this bound.
Yeah, that's correct. Also, I'm using a dynamic, according to the IP address of the user, I know where he's located right now.
Yeah.
And therefore not based just on the static location.
Reverse GeoIP, yeah.
Mm-hmm.
Yeah, we do that too. Everybody does that. Come on, this is as old as the internet.
Is there any other question from the rest of the group? Otherwise, well, it would be great to have the documents you talked about. I can exchange with you by email. We have a Slack channel because all that was born out of a community called Open COVID-19, and so we have a big Slack with more than 1,000 people, but we have a channel there where we do where we share articles and maybe we could invite you there, and so that you can see if you can come to an upcoming event. And I think it would be great to have more of your feedback on the particular interface we'll be doing. So, but it was very interesting, very cool work. Congratulations.
Thank you very much. I thank you for having me here, and we wish to continue the work together. Mm-hmm.
Beautiful. And Pedro is actually the one right now leading the write-up of the paper. So we might also have some elements to share at some point. Yeah, very cool, very cool. So if you can send me, you have my email. So if you can send me material, and I will answer to you with like more details, and that would be great.
Okay, just one last thing. Luba says she had a question, but she cannot unmute herself somehow. Luba, can you just ask your question in the chat, and we'll just...
I cannot unmute her also by clicking, so I think it's...
But I'm in I'm in a place which is very, very noisy, so I don't want you to hear that. But it was a question about location and the location recommendations, where the location is the main thing.
Can you ask your question?
Yeah.
I didn't understand the question, sorry.
Yeah, what's the question, Luba?
The question was whether you had any algorithms which were suggesting something to users, not just based on the location, but also on the topic, basically adding that to the location information.
Oh, that's, I mean, that's
literally... But it's actually an easy thing to do, but I wanted to ask more about your experience.
So I'm not sure if I understand it correctly, but like the hybrid algorithm which I described, it takes into consideration location as well as topic of the project.
Was this your question, Luba? Okay. Well, I guess if you have more material on the hybrid framework, I can share it to Luba.
Okay, great.
Yeah, right. I'm going to have to go because I have another meeting as well. But thank you, Naama. That was really, really cool. I'm very excited about the work you've done. This is like really nice foundational stuff for that kind of work. And we're definitely right in the grunt of it. So this is...
Thank you very much. It is great to hear that there are more works like this.
Yeah.